evening, everyone. You're welcome to the class this evening. This is How About Academy. And so the topic we have before us this evening is on moment of force. You remember in our previous class, we have discussed, we had an introduction to moment. And today we'll be delving deeper into the concept of moment. And so at the end of this class, you should be able to understand the principle of moment. Also, you should be able to resolve, calculations on moment. And so we go straight into the content of our lesson this evening. And so when we talk about principle of moment, we're talking about describing an object which is in an equilibrium position, a stable or not moving position. Now, the principle of moment states that when an object is in equilibrium or is in a stable position or not moving, that the total clockwise moment must, underline the word must, be equal to the anti-clockwise moment about the same pivot point. So when we talk about pivot point, let's say we have something like this in form of a seesaw. Here we have the pivot. This particular support area is what is known as pivot. It is also called fulcrum. This is also called fulcrum. And so, or sometimes you see people calling it support. So we have about 3 names for the same item in case you see teachers mentioning all of these 3 names, don't be confused. One, you can call it a pivot. Pivot. The same thing as pivot. You can also call it support. Support. Or call it fulcrum. So these 3 names explain what is here. So now when you have this plain object lying on this support, now what we are saying is this. Let me explain this concept of clockwise and anti-clockwise in case you don't really understand what it connotes. Now you have the clock here. The clock, a typical clock will go this way. Now you have the movement of the clock this way. Look at the direction of the movement of the clock. And so when you are moving an object in the direction of the movement of the clock, then you say that object is moving in a clockwise movement because this is the clock. So now, if we have something like this, maybe an object, with a certain magnitude or size in form of the force of this object, the force that is acting on this particular plane area. So now when we have this, let's assume we have the weight of this object is 10 Newton. Then we have another object weighing 20 Newton. Newton is the unit of force. So now, I've explained to you that the movement, you use the movement of the clock to explain how these objects, how they move. So now, this is the object, 10 Newton, that is the weight. Now, you also measure, another thing you measure is the distance of the object from the pivot or the support or fulcrum. Now you have these also, the movement from here to this place. Now what happened? Now if you want to calculate the moment of force of this particular object that I've drawn here, what you do is this, the moment of force is calculated using the magnitude of the force multiplied by the perpendicular distance. So what we're saying is this, let's assume this is 3 meters. Remember that meters is the unit of a distance. And here, we don't even know the distance, but we know the magnitude of a force acting on this side. So now what we do, according to the principle of moment, is that the clockwise moment is equal to the anti-clockwise moment. Anti-clockwise moment. Anti-clockwise moment. So this is the mathematical expression of the principle of moment. So now here we see this. Let's assume this is moving in the clockwise moment, and this one is moving in the anti-clockwise moment. So what we do is that we know the weight. The weight is 40 Newton, 10 Newton, multiplied by the perpendicular distance, which is 3 meters, equals to the anti-clockwise. Anti-clockwise, the force there, which is the weight, is 20 Newton, multiplied by d, because we don't know the distance. We're using this to resolve the distance. So what's the next thing we're going to do is to resolve it mathematically. So we have here is going to be 30 Newton. 30 Newton meters, because you have resolved this, equals the unit of moment is Newton meter. So now 20 d. D is the distance, the unknown distance, Newton meters. So now we make d the subject of the formula, which is going to give us 30 divided by 20 equals d. Therefore, d is equal to 1.5 meters. 1.5 meters, because the unit of distance is in meters. And so 1.5 meters. Here we have 30 Newton meter. Here we have 20 Newton. So Newton, we cancel Newton, remaining meters. So we have 1.5 meters. Is that clear? Very clear? Okay, that's good. So now we have this, look at it, a pictorial representation of what the principle of moment depicts. So now we have seen the calculations there. You see it? This is the weight here on this side, the weight here on this other side. Now, we'll talk about moment. We are talking about the turning effect. So we have seen it, we've seen the units and all of that. So I'm going to give you, you're going to have a classwork, and I'm going to give you this as your assignment. So I expect you to copy this now so that you can resolve it. We are going to look at it before the commencement of our next lesson. Is there any question you want to ask me as far as moment is concerned? Any question? Ask me your questions. Now, do you have any question concerning this assignment? Okay, good. So copy it. Then in our next lesson, we are going to look at it before the commencement of the lesson. Thank you very much. I'll see you in the next class.